but I was like nervous the whole time. I actually didn't think
That man was way more interesting than the guy.
I know, like a lot of people do all shopping.
Yeah.
Well, okay, actually,
that girl was
like so
fun.
interesting. I know. Did you watch the men's game?
Not really. I heard about it.
I have your money. You guys want to hear it?
No. Sure.
Okay, so what is a woman's favorite book?
Oh, wow.
Her husband's checkbook.
Nice one, Mike.
Thank you.
Why she always makes us like seriously, come on, like in here, us two girls.
They think I can't hear them talking about me? I'm going to let you in on a little secret. Michael told me last week that I make more than both of them combined.
How does this work?
So who do you think makes the most in the office?
Well, obviously me. I've been working here for 10 years.
So how do you feel about payday?
Great, obviously, because I make the most.
Jake says he makes more than you do.
Wait, what?
What? No, we need to address this.
Can I help you?
So we heard you think you make more money than us.
Well, it's not just me. All men make more money than women.
I'm actually pretty sure that all the girls in here make more money than all the guys.
Hey guys! I can solve this problem for you.
Yeah, okay.
Hypothesis testing for the two-sample case is concerned with the difference between two separate populations. This statistical procedure determines whether or not the difference between the random samples drawn from both groups is large enough to conclude that the populations represented are different. This is done in a 5-step model which shows us how to conduct this procedure by hand. Our research question is there a significant difference of income between men and women in Canada? Our hypothesis is that there is a difference in income. However, we do not predict which gender might earn a higher average income. Our samples came from the 2006 census. Sample 1 includes 772 females who earn an average income of $26,760.41. Sample 2 includes 728 males who earn an average income of $41,197.19. Making assumptions and meeting test requirements. Hypothesis testing for the two-sample case requires that independent random samples are used. That is to say that the samples must be chosen not only randomly, but also independently from one another. Choosing one sample cannot have an effect on choosing the other. The variable in question, in our case income, must also be interval ratio. The assumption being made is that since the sample size is large enough, over 100, the sampling distribution of the differences in sample means will be normal, and thus the normal curve can be used to establish the critical regions. Null hypothesis. The null hypothesis states that the populations represented by the samples are not different for this variable. No direction for the difference has been predicted, so a two-tailed test will be used, as reflected in the research hypothesis. Step 3. Selecting the sampling distribution and establishing the critical region. The sampling distribution is equal to the z-distribution, which will be obtained in step 4. We have set alpha at 0.05. From there, we determine z-critical by looking at column 3 of Appendix A. This gives us the area under the normal curve, 0.025. This corresponds to a z-score of plus or minus 1.96. Alpha, or the probability of error, is commonly set at 0.05, which is what we have chosen as well. This means that there is a 5% chance that the estimate does not fall within the parameters that we have stated. The researcher is 95% confident that the population value falls within this specific range. Step 4. Computing the test statistic. For this step, there are two equations that we need to work through. In order to determine the difference between sample means, we must first determine the standard deviation of the sampling distribution for the sample means. This is often referred to as a pooled estimate. Once we have the answer, we can now move on to determining the differences in sample means, or z obtained. Z obtained is negative 5.65. Step 5. Making a decision and interpreting the results of the test. Now that we have determined both z obtained and z critical, we can use these results to determine whether or not we can reject the null hypothesis. As shown by the normal curve, negative 5.65 falls within the pink area or the critical region. This means that there is a significant difference in the sample means, and thus we can reject the null hypothesis. This test statistic supports the hypothesis that men and women in Canada do earn different incomes. Given the direction of the difference, we also note that specifically men earn more than women. If we have determined both z obtained and z critical, we can use these results to determine whether or not we can reject the null hypothesis. As shown by the normal curve, negative 5.65 falls within the pink area or the critical region. This means that there is a significant difference in the sample means, and thus we can reject the null hypothesis. This test statistic supports the hypothesis that men and women in Canada do earn different incomes. What it can't do. Statistical significance is not the same thing as theoretical or practical importance. A number of factors can affect the probability of rejecting the null hypothesis, which all must be taken into account. These are the size of the observed differences, the alpha level, the use of one or two-tailed tests, and the size of the sample. We do not want to mistake small differences which are statistically significant as being important. Using the dataset of the 2006 General Survey, SPSS can help us to determine the significance of the difference between means. Once you input the dataset, in the main toolbar, click Analyze, then Compare Means, and then Independent Samples t-test. The Independent Samples t-test dialog box will open with the usual list of variables on the left. Find and move the cursor over Total Income and click the top arrow in the middle of the window to move it to the Test Variables box. Next, find and highlight sex and click the arrow in the middle of the window to move sex to the Grouping Variable box. And then the Define Groups button will become active. Females go into Group 1 and males go into Group 2. Define the groups by typing 1 into the top box and 2 into the bottom box. Click Continue to return to the Independent Samples t-test window and click OK to produce the output. The first chart, Group Statistics, provides us with some descriptive statistics. There were 728 males in the sample who earned an average income of $41,197.19. There were 772 females who earned an average income of $26,760.41. We can see from this output that the sample means are different and that, on average, men earn a higher income than women. The results of the test for significance are reported in the next chart, Independent Samples Test. The second chart tells us that we can reject the null hypothesis, since the number in the significance column is less than 0.05, our designated alpha level. The error bar graph helps us to quickly assess if there is a statistically significant difference between two means by examining if the two confidence intervals overlap. To produce an error bar graph of the 95% confidence interval of each mean, click Graphs, Legacy Dialogs, and then Error Bar. The error bar's dialog box appears, with the Simple and Summaries for Groups of Cases buttons already highlighted. These are the ones we want, so just click Define. The Define Simple Error Bar dialog box appears. Transfer the dependent variable, Total Income, to the variable box, and then click OK, and the following error bars will be produced. The error bars show that the sample means, the small circles on each bar, are different, and that on average males earn a higher income than females. Furthermore, the confidence intervals, indicated by the length of each bar, do not overlap, so the means are significantly different from one another.